Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is a 1,2-desubstituted cyclohexane. C1 bears a methyl group and a tertiary ester, C is equal to OCH3 directly on the ring carbon. C2 bears a CH2C is equal to OCH3 group, an acetate type ester via a methylene spacer. Moving on to the next step. Reactivity of the two esters toward pH-MgBr. 1-equiv Grignard reagents react with esters, but the rate and accessibility depend on steric and electronic factors. The ester at C1 is a tertiary ester. The carbonyl carbon is attached to a quaternary carbon bearing CH3 and the ring, making it highly sterically hindered. The ester in the CH2C is equal to OCH3 group is a primary secondary ester. The carbonyl is on the end of a methylene chain, making it far less sterically hindered and more accessible to nucleophilic attack. Moving on to the next step. Because only one equivalent of pH-MgBr is used, it selectively reacts with the less hindered ester. The CH2C is equal to OCH3 ester reacts with pH-MgBr. Normally, a Grignard adds twice to an ester, giving a tertiary alcohol, but with a sterically demanding Grignard like pH-MgBr and careful control, the first addition gives a ketone intermediate after loss of OCH3, and the ketone can be less reactive or the second equivalent is not available. However, in practice with 1-equiv pH-MgBr reacting with the less hindered ester CH2COOH3, the product after workup is the ketone CH2C is equal to OPH, because the tetrahedral intermediate collapses by expelling methoxide to give the ketone and no second equivalent is present to add again. And for the final step, the C1 tertiary ester, C is equal to OCH3, remains unreacted due to steric hindrance. The CH2C is equal to OCH3 is converted to CH2C is equal to OPH. This matches option D. Cyclohexane ring with CH3 and C is equal to OCH3 at C1 unchanged and CH2C is equal to OPH at C2. A and B. These show reaction at the hindered C1 tertiary ester, which is disfavored sterically. Also the ring is not shown in A, B. C. This shows an extra methyl group added to the ring carbon, C2, which would require a different reaction pathway and is not the product of simple ester plus pH-MgBr. Therefore, the correct answer is D. Therefore, the correct answer is option D.